In this video we're going to be looking at collecting like terms. Okay, so as you can see I've got 9 questions here to go through. I'm going to do the first few, then what you can do is pause the video, have a go yourself and see if you get the correct answers. Alternatively, you can just follow them through as I do it, or watch the video first, then you can go back to the beginning, write these down on a bit of paper and then check if you get them correct. So let's start off with the first one. So collecting like terms. So just a brief introduction to what terms are. This is a term, this is a term, this is a term, and this is a term. Okay, so when we're told to collect like terms, we have to look at what are the same. So for example, the number 2 and the number 3 are like terms because they are the same, they are just a number. If we look at these here, so the 4a and the 5a, the numbers are associated with a, so that makes them a type of term. So one way to look at it is you could say that 4a is talking about 4 lots of apples. Okay, so you can't mix, for example, apples with oranges. If you're going shopping and you've got a shopping basket and you're trying to collect like terms, you can't say I've got a mixture of the two. It's either you've got 5 apples and 4 oranges. You can't say I've got 5 apple oranges. It doesn't work like that. So it's the same kind of principle here. So if we have a look, we've got 4a and 5a. So what I tend to do is I'll always start with the first term given. Okay, some people jump and say, oh, I'm going to do the numbers first. That could lead to confusion. Okay, and you could skip or miss something out. So just start with the left, what you're given, and work through it. You can also underline it like I've done here. So go through, get a multicolour pen, and go through the terms. So if I've got 4a, I then scan for other terms which have a in them. Okay, so it could be 1a, could be 50a, etc. So if I scan this from left to right, I can see there's 4a and it's a plus 5a. Now this is very important. Okay, the sign to the left of a term is associated with it, so that means this is a positive 5a. You cannot ignore it. Okay, now when it's a positive, it's less important. Okay, it doesn't matter as much, you can get away with making mistakes. But when it's a negative, okay, people will assume it's positive, and that's where the mistake happens. So this is 4a plus 5a. So then you've got 4a, whatever a may be, plus 5a. So 4 plus 5 gives you 9a. Okay, then what you can do is you can just do a little tick by the a's just to make sure that you've done all of the a's possible. Then you move on to the number. So I've got 2 plus 3. So then 2 plus 3 will give us a plus 5, and that's that term collected. Okay. And that's that expression simplified and collected. Now if we go on to question 2, again I'm going to start with 3x because it's the first thing I've got. So I scan the expression here, 3x, I look for other x, and here I've got minus 2x. Notice I do not say I've got 2x, I have minus 2x. That's very important because now it's 3x minus 2x. So 3x minus 2x will give us 1x. So I can write either 1x or just x, because I have one of them. So it's up to you. If you'd like to put 1x, you can put that, or you can put just x. I then move on to my second term, which is a plus 5, so we're dealing with numbers. I then scan the expression to see that there's a minus 1. So plus 5 minus 1 will give us plus 4. And that's question 2 answered. Right, if we look at question 3, we're starting with r. So for r, again scan the expression for other r's. From left to right, I see that there's minus 4r. So if I've got 4r, take away 4r, that leaves me with nothing. I do not need to write 0r. Okay, I can just forget about it. I then look at plus 2s, plus 3s. So plus 2s plus 3s will give us plus 5s, or just 5s. And that is the answer. Okay. If we move on to question 4, I have minus 5t, scan again for other t's, plus 5t. So minus 5 plus 5 will give us 0. Again, I do not need to write 0t, so I can forget about that, and I'm just left with the plus 1. Oh, I should have done that in a different color. I'm just left with the plus 1. So my answer is 1. If I then look at question number 5, again you can pause this if you think you got it. Pause this, have a go at the remaining questions. For number 5, I'm going to start again with the first term, which is minus 10s. Scan left to right for other s terms. So minus 10s, and that's all I've got. So now I do minus 10, which gives me minus 20s. Okay, remember the number line, which direction it goes. And then I move on to my next term. So again, I haven't been doing it, but you can tick this off if you'd like to. And just be careful that it doesn't get too messy. And then I've got plus 32. And then look for other terms like this, of numbers where it's just the number and there's no variable attached. So it's plus 32 and plus 3. So plus 32 plus 3 gives me plus 35. Right, now moving on to question 6. When we're collecting terms, they just have to be alike. Okay, so if I look at this first one, it's x squared. So I need to scan this expression for other terms that have x squared in it, which is this one here. Okay, now don't forget, this is 1x squared, so I can leave that written there if that makes it easier for you to see. So I've got 1x squared plus 2x squared. Okay, so the like term here is the x squared part. This one here is saying that there's 1x squared, and this one here is saying there's 2 lots of x squared. So if I collect them or add them all together, I have 1x squared plus 2x squared, which gives me 3x squared. I've then got minus 5. I scan the expression. Minus 5 is the only number by itself, so therefore it is minus 5. Okay. Right, if I move on to question 7, I have 4t squared. So I scan the expression for other t squareds, okay, which is here. So 4t squared plus t squared will give me 6t squared. I then have minus 7. Scan the expression, minus 7 is the only number there, so minus 7. I then have plus x squared. Scan the expression, x squared is by itself, so plus x squared. Okay, you can't just leave it because it still exists in the expression. So if there's nothing you can collect it with, so there's no addition or subtraction for you to do, you have to write what is there. Okay. Right, for question number 8, I've got minus 5m to the power 3, or m cubed. I then have to look for other terms which are m cubed, okay, because this is saying that there's minus 5m cubes, but m cubed is what I need to be looking for in the expression. So this next one, 2m squared, isn't the same as m cubed, so I skip that. I go to this one here, 6m cubed. So if I've got minus 5m cubed plus 6m cubed, I'm going to have 1m cubed, so plus 1m cubed. So I'm just going to write m cubed, but if you want, you can write 1m cubed at the front. Okay, I then move on to the next term, so 2m squared minus 4m squared. So if I've got 2m squared, take away 4m squared, I will have minus 2m squared. Okay, moving on to the last question. If you haven't paused it already, pause this now and give this question 9 a go. See if you can get the correct collection of terms. Right, so with this one, I'm going to start off with minus 3z squared. I'm then going to scan the expression like we've been doing for other z squared. So 26 minus 2, 10z, no. Then I've got this 3z squared here. So if I've got minus 3z squared minus 3z squared, that's going to give me minus 6z squared. I've then got plus 26 minus 2, so plus 26 minus 22 is going to give me plus 24. And then I've got plus 10z, scan the expression, that's all there is for z, therefore I will write plus 10z. Okay, and that is a quick overview of how you collect like terms. Now if you enjoyed this video, drop a like on it. If you've got any questions about this video, make sure you comment down below. Okay, if you've got any video ideas that you want to see on this channel, also let me know down there. And make sure you subscribe because you'll get notifications of when I post videos, which I'll be doing on a regular basis.